Hello there. So this is the introductory video to introduce section 4.1 in the text, which is the first section in the text that introduces the idea of forces. So this entire module is the module where we begin to look at, we move on from looking at how things move, which was in the previous two modules. Now in module 4, we look at why things may start to move in the first place. And the reason why things move is because they've been subjected to what's known as a force. So what is a force? A force is a push or a pull or a grip. So if something experiences a force, it's either getting pulled or it's getting pushed, or forces can also grip things in place, things that are trying to move, because they're subjected to some other force, but there's a force that can exist that can actually grip it and prevent it from moving. So now, as you can imagine, a force is it has a magnitude, right? So you're pushing a certain amount or pulling a certain to a certain degree, and it has a direction. You're pulling or pushing in a direction, and so you can think of a force as being a vector quantity, because not only do they have magnitude and direction, they add head to tail, just like vectors. So forces are vectors. And so the question that you may have in mind is how do we actually measure forces? What are the units of force? So the unit of force that we use in physics, at least the SI unit, is known as the Newton. And it's named after Isaac Newton, who we'll learn more about in future sections. So if I can just go to the whiteboard real quick here, and we can write some of these ideas down. So a force equals a push, a pull, or a grip. And the SI unit of force is known as the Newton. And a Newton is defined such that 1 Newton equals 1 kilogram meter per second squared. So this is what we call a derived unit. You construct this unit out of other units within the SI system to define it. Now, if you think back to chapter 1, where we were talking about units and measurements and so on, it was discussed how you measure lengths of things, say, in meters. And what a meter actually is a standard length that is internationally agreed upon, so that if you have to measure some arbitrary length, you count the number of these standard meter units fit inside, and then that allows you to quote that distance in meters. So similarly, you can do a similar thing with forces. In the book, they talk about how if you stretch a spring, the spring pulls back with an amount of force that gets stronger the farther you pull the spring. So if you have like a standard spring that you stretch by a standard amount, you can define that to be 1 Newton, and then if everyone agrees to that same spring and that same amount of stretch, that would be enough to define the strength or the size of the Newton. But there's other ways of producing forces, right? There's gravity produces force, right? There's the force of gravity pulling you down to the ground. Magnets, are attracted to each other. That's a force, right? They pull on each other. So there's many different ways you could think of constructing a standard for a force. And we'll look at some of those later on. But for right now, realize that the SI unit of force is the Newton, and a Newton is equivalent to 1 kilogram meters per second squared.